Good evening, friends. In today's video, we'll talk about the momentum. So if I talk about the momentum is basically represented with the symbol P, and it is equal to the product of mass and velocity. So it is equal to mass times velocity. And momentum is a vector quantity. That's why I've represented with an arrow on top. So it's a vector quantity. A vector quantity means what? It has direction and as well as magnitude. So basically, if let's say there is a car which is moving in the forward direction at 10 meters per second, and the mass of the car, this is the velocity, and the mass of the car is equal to, let's say, 1000 kgs, and I wanted to find the momentum, and because this is the velocity, so I have to represent the direction also. Let's say this car is moving in the east direction, so the momentum will be equal to mass times velocity, which will be equal to 1000 times 10, which will be equal to 10,000 kg meters per second in east direction. So kg meters per second becomes the unit of the momentum. Now let's take another example. Let's say the same car, now it is moving in the west direction, okay, and this is moving with again 10 meters per second, and the mass of the car is equal to 1000 kgs. I wanted to find the momentum. I'll encourage you guys to pause the video and find the answer for this one. Let's look into what you've got and whether that matches with the answer or not. So momentum value will be equal to, again, mass times velocity. So the mass is equal to 1000, and this is times by 10, and then this 10 is in the west direction, 10 meters per second. So I will place a negative 10 here, because what we generally do is whenever an object is moving in west direction, we consider the sign convention as negative. When the object is moving in east direction, we consider it as positive. If an object is moving in the north direction, we consider it as positive. In south direction, it is considered as negative. So right now the car is moving in the west direction, so that's why I've considered the sign convention as negative here. And then 1000 times 10, it will be negative 10,000. Again, the units will be, units of mass is kg and units of velocity is meters per second. So the final units for momentum value will be equal to kg meters per second. And I can also write it as momentum equal to 10,000 kg meters per second in west direction. So that's what momentum is. It is equal to product of mass and velocity. So momentum, definition of momentum is product of mass and velocity. That's what momentum means. Now this was pretty straightforward. Now let's say if a car which is moving in east direction, again this is moving in east direction, again with 10 meters per second, and then all of a sudden the velocity changes to 30 meters per second. Again, mass of the car, I'm gonna consider it as 1000 kgs. So I wanted to find what is the change in momentum. So to do that, I will first of all, I'll find the initial momentum, P initial, which is associated with this 10 meters per second, and then I will find the P final, which will be with respect to the 30 meters per second. So initial momentum is equal to 1000 times 10, that will be 10,000 kg meters per second. P initial, I'm not writing the units here, but make sure in exams you guys do write the units. So P final value will be equal to 1000 times 30, this will be equal to 30,000 kg meters per second. So change in momentum is what? Delta P equal to P final minus P initial. That will come out as 30,000 minus 10,000. So that will be equal to 20,000 kg meters per second. And again, in both the cases, the car was, I haven't shown the direction, but the car is moving in the east direction. So this is east, so that's why I kept this value as positive, this value as positive. I can place a positive here, and this is already given me as a positive number. I can also show a positive so that there is no confusion, and this negative and a positive will make into a negative number, and then 30,000 minus 10,000 will give me a 20,000 kg meters per second as my answer. Now let's complicate this problem. So the same car, which is initially moving with 10 meters per second in east direction, after a certain time it is moving in the west direction now with, let's say, 30 meters per second. All right, and this is moving in west direction. Initially it was moving in east direction. So I wanted to find change in momentum. What will be the answer for that? So change in momentum value will be equal to, again, delta P. Delta means change. This symbol is the representation of change. This is called delta. So delta P is equal to P final minus P initial. So the initial momentum is, P initial is equal to, I can take it from the previous, or you can calculate it also. Again, the mass of the car is 1000 kgs. So it will be 1000 times 10, which is 10,000 kg meters per second, and P final is equal to, this was in east direction, so I kept this number as positive. Right now this is in west direction, so what I'm going to do is I'll say P final is equal to mv. Mass is 1000 kgs. Mass is a scalar quantity, but velocity is a vector quantity, so I'll multiply it by negative 30. So this will come out to be negative 30,000 kg meters per second. So P final is negative 30,000 minus 10,000, and that will be equal to negative 40,000 kg meters per second. So that's how we can find out the change in momentum, or I can write it as delta P equal to 40,000 kg meters per second in west direction, because this is the final sign. The final answer has negative into this into it, so that's why I can change the sign and I will represent it with the west direction as my final answer. Now let's move into another question. Let's say if you are given that the momentum is equal to, I'm gonna keep a very simple number. Let's say the number is let's say the momentum is 100 kg meters per second, and the mass of the object given to me is 1 kg, and I've been asked to find the velocity. So find velocity. right? And then this is given to me in east direction. So how can I find the velocity? Momentum is equal to mv, and mass is given to me 1 kg, and velocity is what I wanted to find out. The momentum is 100, so dividing both sides by 1, which actually will end up leading to the same number, so this will give me 100 meters per second is the final answer for the velocity. And because this is a positive number already, because it was moving in the east direction, so I kept this number as positive, and the final answer also comes as positive. So velocity is equal to 100 meters per second. It is 100 meters per second in east direction. Let's make it a little more complicated. Let's say the momentum is equal to 50 kg meters per second, and the mass is equal to 10 kgs of the object. Find the velocity, and the momentum given to me is in west direction. Find velocity. So velocity value will be equal to, again I'll write down the formula, momentum equal to mv, and the momentum I can write it as negative 50 because it's in the west direction, so that's why I've placed a negative sign here, equal to 10 times velocity, and then dividing both sides by 10, that will lead to the final answer for velocity, which comes out to be negative 5 meters per second, or I can say velocity equal to 5 meters per second in west direction also. Now let's make these problems a little more complicated. So let's say the momentum given to me is 30 kg meters per second in east direction. That's the initial momentum given to me of an object. So there is some random object which is moving in east direction and has a momentum of 30 kg meters per second. That's given to me. Now if the velocity of this object increases by twice, what will be the final momentum? So this is a little different from the previous question. In this, the velocity is not given to me, so I wanted to find the final momentum with respect to the initial momentum. So I'll encourage you guys to pause the video and try and solve it at your end, and then come back and match your answer. So let's look into it. So the momentum formula which we've done is equal to mass times velocity. So if I look into this formula tells me a couple of things, that if I increase the mass value, then the momentum will also increase by the same proportion. If I increase the velocity value, still the momentum value will increase. From the looks of this formula, it tells me either I increase the mass or the velocity, the momentum will equally increase in the same proportion. So if the initial momentum given to me is 30 kg meters per second, and now the velocity has increased by 2 times, what will be the final momentum? So if the velocity is increased by twice, the momentum will also increase by 2 times. So the final momentum will be 60 kg meters per second. That will be the final momentum. Now what we're going to do is we're going to make it a little more complicated. So let's say the initial momentum is 30 kg meters per second. 30 kg meters per second. That's given to me. and then velocity increases by 3 times, let's say 3 times. So what I'm going to write it as v final equal to 3 times of v initial, and mass reduces by half of the given value. M final is equal to half of m initial. Find the final momentum. So I can write it as m final equal to 0.5 of m initial also. Both means one and the same thing. So do not confuse yourself. 1/2 is equal to 0.5. I wanted to find the final momentum in this case. So again, if the velocity increases by 3 times, what I'm going to do is I'll write the initial momentum value, which is 30, and then I will multiply this with 3, because remember the formula, momentum is equal to mass times velocity. So momentum is directly proportional to mass, momentum is directly proportional to velocity. So what does that mean? If I am increasing it by, let's say, 2 times, 3 times, or 4 times, the momentum will also increase by same amount of time. So if I've increased it by twice, this will increase by twice. If I increase this by 3, this will increase by 3 times. Same goes with the mass also. So because the velocity has increased by 3 times, so the momentum has increased by 3 times, which is equal to 30 times 3, which will be equal to 90. And then mass has reduced by half, so I'll multiply it by 0.5. So that will give me the final answer as 45 P final equal to 45 kg meters per second. And basically I've kept the in this I haven't talked about the direction, so I'm assuming that the direction is pretty much the same. The object is moving in the east direction has not changed. So this is a positive number, this will be an east direction. Now let's make this question a little more complicated. So if we are given the initial momentum, P initial is equal to 30 kg meters per second. All right, or rather than taking taking this number, what I'm going to do is I'm going to provide you the velocity value. So let's say if the velocity value is given to me, so the initial velocity of a given rocket is 8.5 meters per second. So there is a very small rocket which a student has designed, and this is moving with an initial velocity of 8.5 meters per second in the upward direction. And then because this is a rocket, this contains certain fuel, and while it is moving upward, and the fuel will burn off, and then the mass of this rocket will reduce. So I'm gonna say that the mass final is equal to 0.5 of mass initial. Let's say this is also given to me. While reaching on top, not exactly on top, while reaching up to a certain distance, the mass reduced to half. Okay, so here the mass m final is equal to 0.5 m initial, and this is the situation given to me. I wanted to find what will be the velocity, when mass is halved. That's what I wanted to find out. So what I'm going to do in this question is I'm going to again write down the formula of momentum. Momentum equal to mass times velocity. Now, earlier question, if I go back into the previous question, in this question I was provided with the value of momentum, and I directly wrote down the formula and said that momentum is proportional to mass, momentum is proportional to velocity, by using the formula P equal to mv, and I was able to find out the answer. But in this case I've been provided with the velocity initial and I've been asked to find the velocity final. So what I'm going to do is I'm going to write this formula in terms of velocity. So what is the relation between momentum and velocity? So I'm going to divide both sides with mass. So mv divided by m on both sides. So the velocity value is equal to momentum divided by mass. So what does this means? This means that if the momentum, the velocity will increase with the momentum. So velocity is directly proportional to momentum. So if I increase the velocity by 2 times, momentum increases by 2 times. Or I can also say that if I increase the momentum by 2 times, then the velocity will increase by 2 times. Whereas velocity is inversely proportional to mass. So what does this mean? That if I increase the mass value, then what's gonna happen? Velocity will come down, isn't it? By the looks of this formula, if you look into this formula. So basically, if I increase this by 2 times, the velocity will reduce by 2 times. That's what's gonna happen. And one of the piece of information which I'm missing, which I haven't given you guys in the question, is that the momentum has also changed. So I'm going to assume that the momentum has increased by a factor of 4 in the given question. So I will write here, I'm going to erase and make some space here. So the momentum in the given question, another piece of information which I have missed. So P final is equal to 4 times P initial, means when the mass is halved, the momentum has increased to 4 times. P final here is equal to 4 times P initial, and I wanted to find the final velocity in this case. So I will rewrite the formula and we will use the concepts which we've learned. P equal to mv, and dividing both sides by m, and this will be equal to P upon m equal to v. Now based on this, if I increase the velocity, if I increase the mass by momentum by 4 times, shall I say. So momentum has increased by 4 times, so velocity will increase by 4 times. So 8.5 times it by 4. So v final will be equal to, because remember we've said the velocity is, from the looks of this formula I can say that velocity is directly proportional to the momentum and inversely proportional to the mass. So if mass increases, velocity will go down, and whereas if momentum increases, the velocity will increase. So we multiplied by this number, and then this will come out to be 34. So this is not actually the final value, this is just an impact of momentum. Now we will also try and find out the impact of mass also. So mass, final mass is 0.5 times of the initial mass. So what I'm going to do is I'll place 0.5 down here. Because this number is less than 1, so this will actually end up increasing the final velocity. So basically what's happening is final mass is reducing, it's not increasing. So that's why the final velocity has gone up. So the final velocity is 68 meters per second. And it will be in the same direction upwards. So that will be the answer. So hopefully I was able to give you guys some brief knowledge about the momentum, and I'll see you guys in the next class. Have a good day. Bye.